Hey calculus students, we are going over Handout 20, the substitution rule. Thank you for sticking with me so far. We are almost here at the end, just a little bit further, and you will have made it through Cal 1. So let's go ahead and go over this. Like I said, we're going over the substitution rule. This is section 5.5 in your book. Basically what we're going to be doing here is reversing the chain rule, right? So reversing the chain rule. So how do we do that? Well, I will show you how to do that. First off, we have to let u equal g of x. That is, we got to let u equal this, whatever is inside this function. So anything that simplifies what we are doing. And then we take the derivative of both sides. So we have du dx equals, the derivative of g, right? And so we can, this is equivalent to saying du g prime x dx. And so we'll be substituting this guy in for this guy there. And so note, when we make the proper substitutions, this is simply going to become the integral of f of u du. And so you can see it's a much simpler form, right? We don't have a function within a function to work with anymore, just and then multiply by another function. It's just a simple function of one variable, u, and then we're taking the antiderivative with respect to that variable. All right? And when you're trying to figure out what u to make your substitution, it should always be a substitution that simplifies the equation. Right? If you pick a u and it does not simplify the equation, it's a really good chance you need to pick a different u. So let's look at some of these examples. Notice right here we have a function within a function, right? We've got a square root, so that makes things a little bit tricky. So we want to get rid of that. So we're going to let u equal x cubed plus 2. And then du equals 3x squared dx. And so we notice that this 3x squared dx, is the same as, this that I've highlighted in green. And so we can restate this whole thing as the integral of the square root of u du, which is the same thing as this integral of u to the 1/2 power du. And now we're going to apply the power rule as it goes for antiderivatives. So keep in mind that means we're going to be adding 1 to the exponent, not subtracting it like we would if it were a derivative. And so we've got u to the 1/2 plus 1 is 3/2. So u over 3/2, and don't forget that constant. All integrals, or if they're an indefinite integral, have to be the most general antiderivative. And that means you have to add a constant if you see an integral. Right, so this becomes 2/3, right? Because we're just flipping that one to get up top. And then we're going to go ahead and substitute that u in. Right there. And so that's x cubed plus 2. And there we go. That's it. That is the answer. And so if you take the derivative of this guy, you will get everything inside the square root. That is called the integrand right there. Okay, so let's come on over to this next guy. What could possibly simplify this but the expression that is inside the cosine function? So let's highlight that so we have an idea of what we're working with. And we're going to let u equal that guy that we've highlighted. Awesome. So let's go ahead and take the derivative. Du equals 6x to the 5th dx. And note something here. This expression here does not match this expression here. So it means we've got to do a little bit of surgery. We're going to divide both sides by 6. That's what we got to do. So we have an x to the 5th dx. We have x to the 5th dx. All right, awesome. We got them to match. So we got to make our appropriate substitutions. So it's the integral of cosine of u. And then we're going to put in our green bit. Well, that's du over 6. All right, and so what do I need to take the derivative to get cosine? Well, that's just sine, because the derivative of sine is cosine. Don't forget to add the constant. Awesome, so that one's pretty straightforward. Let's go ahead and make the final substitution right here. And there we are, that's it, that's the answer. 1/6 of the sine x to the 6 plus 3. Don't forget to add that constant. Next problem. All right, we got another square root here. Let's go ahead and highlight that square root. And we're going to let u equal that yellow bit there. And then take the derivative. So that we have negative 2x dx. So note again, they don't match. So we're going to go ahead and do a little surgery. Divide both sides by negative 2 so that we have x dx. And so note now, x dx, right? That matches what's left over. If what's left over is not being subsumed by what you're substituting in, you're doing a little something wrong. So let's go ahead and make our appropriate substitutions now. Yellow to yellow, green to green. So the integral of u, and then the green is negative du divided by 2. All right, so we can bring that negative 1/2 out to the front. And we are, again, taking the integral of u to the 1/2 power. All right, so don't forget, we are adding 1 to the exponent because this is an antiderivative. And so we've got u to the 3/2 power divided by 3/2. Don't forget to add the constant. All right? And so we're going to go and work this through. This is going to simplify to a negative 1/3. All right, we're going to go make that substitution right there. Don't forget to add the constant. All right, and in case you're wondering where this 2 went, well, it canceled with this guy here. All right, so now we just plop in our u in terms of x there, and there we are. There we have it. That is our answer. Okay. And so if you take the derivative of this guy, you will get the original integrand right back. All right, so let's look at the next guy. And I do encourage you to pause the video and attempt to work these on your own. Make sure you understand them. You'll find out if there are any holes in your understanding very quickly if you do it that way, and be able to fix them right away. So please pause the video on each one of these just to make sure you know what you're doing, and then watch my explanation to make sure that you understood properly. All right, so again, we're going to go ahead and say that's pi over 2 times t. du is simply pi over 2 dt. All right, so we need to go ahead and do a little bit of surgery here. 2 over pi equals dt, because that's all we have. Alright, so make the appropriate substitutions. Cosine of u times, don't forget that du there, times 2 over pi du. Alright, and now we evaluate that. Derivative of sine is cosine, so we write sine of u plus the constant. Alright, now all we got to do is substitute our expression for x back in. 2 over pi times sine of pi over 2t, and then add the constant. And there we are. That's it. That's the answer. Okay. And you can check any of these answers by taking the derivative to make sure you get the integrand right back. All right. All right, so in this one, we don't really have a function within a function, but we note that, the derivative of one of these guys, we can kind of get the other one. Let's pick sine, since we don't have to worry about a negative right off the bat. So we're going to make that our u. All right, so it's a little bit different right now. So we get u equals sine x, and then du equals cosine x dx. And you could have just as easily have picked u to equal cosine x, just you would have had to have eventually dealt with a negative sign that was going to come up. But it's okay, it's fine. Alright, so when we take the derivative, we get this right here. So cosine x dx. Note those do match. And you could have easily done it the other way, but you just would have, dealt with a negative number like I was telling you. And so this equals the integral. Let's go ahead and get some color matching so it's a little easier to see. Of u du. Alright, so notice how that went from a trig problem to a non-trig problem very quickly. So now all we have to do is take the antiderivative. So it's u squared divided by 2, right? It's the opposite of the power rule, don't forget. Plus c. Alright, we're making our substitution. And so we put in here sine squared of x all over 2 plus c. And there we are, that's it, that's the answer. Alright, since I already know some of you are probably already wondering what would have happened if I had let u equal cosine instead of sine, well, I went ahead and worked through this right here for you already. And so notice everything's kind of the same, just we swapped. And if you work through it this way, you will end up with this expression. And you might look at these two and go, well, hey, wait a minute, these don't look quite the same. Well, the reason that they are the same is this constant right here. This is an arbitrary constant. The constant in this guy is not necessarily the same as a constant here. Right? And so if you worked it through this way, let's go ahead. You in graph it, you'll notice that they only differ by a constant. So let's go ahead and take a look. So the green is when we worked it with one way, we got the substitution of cosine, and then this one we got the sine, right? Negative up here. And so they appear to be the exact same function, just differing by a constant. And you might notice that how much do they differ by? Well, they differ by they have a difference between the two of 0.5, right? So that's the difference between the two constants if you were to work this out. So that's what's going on. So if you did try to work it out with using u substitution for the other trig function, you would have gotten an answer that looked different, but it really would have been the same. All right. So let's go ahead and move forward. I want you guys to go and try and solve this on your own. Press the pause button. All right, so note we're saying u equals x squared plus 1. And so du equals 2x. dx. And let's go ahead and bring that 2 over, so we have a nice clean x dx over here. I'm going to go ahead and restate this equation here as the integral of x squared times the square root of x squared plus 1 multiplied by x dx. I'm going to go and move that over so we aren't crowding ourselves there. There we go. And I'm going to go ahead and restate that so it looks a little bit cleaner. There we go. All right. So note that, this guy matches here. And then, of course, what's inside matches right here. But we still have this hanging out. We have a way of dealing with them. Look right here. Note we can restate this equation as x squared equals u minus 1. Right, so we can replace x squared with u minus 1. So now all of a sudden we can get rid of all the x's, and this will simplify. So we have u minus 1 multiplied by the square root of u du. Let's go ahead and highlight everything so it's nice and easy to see. Right, that's where everything happens. So let's go ahead and distribute the square root of u. And so we have the integral of u to the 3/2 power, right? Because there is a 1 exponent right there. And this is a 1/2 exponent. And then minus the square root of u, which is u to the 1/2. And that's du. Now all we have to do is take the antiderivative of both. And so 3/2 plus 1, that's going to be 5/2. And then minus u to the 3/2 divided by 3/2. And this will all be plus some arbitrary constant. And so we've got a 2 over 5 times u to the 5/2 minus 2 over 3 times u to the 3/2. All right, and so let's go ahead and plug in our u values there. X squared plus 1, x squared plus 1. And there we are. There we have it. All right, so let's go ahead and move forward. The antiderivative of tan of x. Yes, I know that we've already worked this through and have a nice proof with the quotient rule, but I feel that we can also use this as an example of how to use the u substitution. First, we're going to break this down as the integral of sine of x over cosine of x dx. And then we make a u substitution. Right, we're going to go ahead and use the trig function on the bottom, right, because we want to get a dx out of it. So we have u equals cosine x, we take the derivative, and so we get the du is negative sine of x dx. Alright, so far, so good. So we're trying to match up sine x dx. We got a little negative sign there. Not a problem for us. Just move that negative over. We got it. And so we're going to rewrite this as the integral of du divided by u. Nice. All right. So let's go ahead and work this. Remember, this is u to the negative 1. All right. And so this becomes the, oh, don't forget the negative sign there. So this becomes the negative natural log of u plus c, because if you take the derivative of the natural log of u, you get 1 over u. So let's go ahead and make our substitution in. And so we get the negative natural log of the cosine of x plus c. And if you take the derivative of this, you will get the integrand right back. Alright, so let's look at cotangent of x. We've taken the derivative of cotangent of x, now we're taking the integral. Alright, so we have u equals, well, let's go ahead and break this down first. And so, remember with tan, it's sine over cosine, so with cotangent, it is cosine x over sine x. And so u is simply sine of x, and du is going to be cosine x dx, an exact match for what we're looking for here. Alright, and so this all becomes the integral of du divided by u, which is simply, as we saw before, the natural log of u plus a constant. And so this is the natural log of the sine of x plus c. And there we are, that's it. That's the integral of the cotangent of x. Alright. So now we've got a good feel for how to work with the u substitution for indefinite integrals. Now we're going to look at definite integrals. And so basically it's the same thing, right? We're still going to be looking at taking this as our u. Right? We're still going to say, all right, well, let's let u equal g of x so that du equals g prime x dx, right? That's still in play, still what we're doing, still the name of the game. However, we have an a, and then we've got a b. So how do we know? Whenever we change the variable, the bounds are going to be changing as well. So what are we going to do? Well, first we got to figure out, okay, so what is this first bound? That's going to be g of b. And this is going to be g of a. That's all there is to it. Right? You just got to make sure you change the bounds when you do this so that it reflects the new reality of the variable you're working with. So you'll be doing this instead of substituting the u back in. Alright, so let's run through one of these, make sure it makes sense. Alright, so note that that's kind of causing us a little trouble, what I have in yellow, so we're going to go ahead and do a u substitution on that. du equals 2x dx. Right, so we're looking for a match for here and here, and we got it. And so this becomes the integral of e to the u du. We still have to deal with this guy and this guy. So first off, what is u of 2? It's going to be 4, right? Because it's 2 squared. What is u of 0? Well, 0 squared is 0. That's it. That's all we do. And so now we just take the antiderivative, which is e to the u. That is a u. And we're going from u equals 0 up to u equals 4. That's it. So we've got e to the 4th minus e to the 0. And as you hopefully recall, e to the 0 is just 1. So this is simply e to the 4th minus 1, and that's it. That's the answer. All right, so please try this next one on your own before watching my solution. So we have here, that's our 1 over x. So u equals 1 divided by x. Du is simply negative 1 over x squared dx. And so we got to make sure we plug everything in. And when we do, I do notice that there's going to be a problem because u to the 2, well, that's 1/2. That's not an issue. What about u to the 0? Well, that's going to be 1 divided by 0. That is a problem. Here's what we're going to do. And you might have noticed that if you would have plugged in 0, the whole function is undefined. So let's go ahead and just do a quick edit here, something that we can work with. So if the correct answer for this would have been undefined, but I want there to be a definite answer. So let's just change that to a 1. Okay, and that's how we're going to deal with that. And so this is going to become u to the u of 1, which is 1 over 1, and it's 1. So there we are. And so we have the integral from 1/2, from 1 to 1/2. And this will be of e to the u. And then negative du. Right, because to get the match, we had to move this negative over on this side, right here. Right, so now we got that to match. Everything seems happy here. So let's go ahead and move forward. And so we've got negative e to the u. And this is where u is going from 1 to 1/2. Right, and it's always going to be the second one minus the first one. So we have e to the 1/2 minus e to the first power. Let's go ahead and distribute this negative across so that we get e minus e to the 1/2. Okay. And there we are, that's it. That's the answer. All right, moving forward. So note what we have here. We've got a sine of x. So we're going to make that u substitution. U of sine of x, so that du equals cosine x dx. So you see we have a nice exact match. And so this is going to end up being sine of u du. Note, I'm being very careful not to write the bounds in just yet. Alright, so first we've got to figure out what the bounds are. So u of pi over 2, right, it's going to be sine of pi over 2. And sine of pi over 2, that's when we're pointing straight up on the unit circle. So that's 1. And then u of 0, that's when we've got a horizontal right on the x-axis of the unit circle. So that's going to be 0. So we're going from 0 to 1. All right. So let's go ahead and evaluate this. So we've got cosine of u. Now if I take the derivative of cosine, what do I get? I get negative sine. So I need to put a negative right there. And we are going from u equals 0 to u equals 1. And so this is simply negative, no, I'm drawing the negative outside of the cosine of 1 minus cosine of 0. And what is cosine of 0? Cosine of 0 is in fact 1. And so this is negative cosine of 1 minus 1. Well, like that. If you distribute that, it becomes 1 minus cosine 1. And there we are. That's it. That's the answer. Please note that that number 1 is not 1 degree. That is 1 radian. Right? I want you to keep that in mind when you're working with these functions and taking the derivatives and integrals. It's always going to be in radians. Alright, so this one, you should see that the u is simply going to be this cosine of x. And so du is negative sine of x dx. Let's go ahead and move that negative over right now while we're thinking about it. Alright, so we can see that this sine x dx is satisfied. U is cosine x, so we're going to write this as u squared, right? Because there's two cosines, so it's u squared over a negative du. And let's go ahead and take a look at the bounds. U of pi over 6 equals cosine of pi over 6, which is root 3 over 2. And then we've got u of 0, which is cosine 0, which we just talked about, is 1. So we're going from 1 to the root 3 over 2. Alright, so let's go ahead and further evaluate this. Negative signs out front. So when we work this through, keep in mind that's u to the negative 2 exponent, right? That's what that means. And so negative 2 plus 1 is negative 1. Don't forget the negative sign there. And then we go from u equals 1 to u equals root 3 over 2. Alright, so let's go ahead and work this. Note, negative times a negative, so we don't have to worry about those anymore. And u to the negative 1 is just 1 over u, so it's going to be 1 over root 3 over 2 minus 1 over 1. And that simplifies to 2 over root 3 minus 1. We don't like that format, so it's going to be 2 root 3 over 3 minus 1. Okay, and that's a good answer. We can combine the fractions if we want, so that it'll be 2 root 3 minus 3 all over 3. That's also an acceptable answer. Either one of these would work. All right. Next one, make sure you press the pause button on this one. This is one that you should be able to do on your own, or at least get pretty far with it. If not, it's okay. We're going to go over it. All right, so that's the guy we want to look at. So we have u equals cosine x, du equals negative sine x dx. And go ahead and move that negative over so that we can go ahead and observe our exact match there. Nice, all right. So we have the integral of e to the u du. Okay, so all that works. Now let's take a look at our bounds. U of pi over 2. Well, that's the same thing as cosine pi over 2, which is 0. And then u of 0, which is the same thing as cosine 0, which is 1. So we're going from down here at 1 to 0, right? So, and note, we've got, the bigger numbers in the down on the bottom. We've seen this before. We can rewrite this as negative integral from 0 to 1 eu du. All right, so let's go ahead and take the antiderivative of this. Oh, I'm sorry. I meant to put a negative right there. And then, so that way when you flip the signs, that negative sign is going to drop off. There we go. Okay, good. Make sure that makes sense. So let me restate that one more time. We made a substitution right over here. Let me go ahead and include that in the green. And so whenever we flip the bounds here, right, the bounds here and the bounds here, we were able, you can change the bounds, but recall the rule that if you flip the bounds, then you change the sign. So that's exactly what we did right there. All right, so let's go ahead and evaluate this. This is going to be e to the first minus e to the 0, which is simply e minus 1. Nice. Okay. Moving forward. All right, so this is an interesting looking one. And it's interesting in that we're going to have to be a little tricky in our substitution. We're going to be going backwards and forwards, but it will not be so difficult that it will be completely mind-boggling, but we will get through this. So, obviously the u substitution that makes things simple is what I've highlighted in yellow. So u equals 1 plus the square root of x. And so that du equals 1/2 x to the negative 1/2. All right, so this x to the negative 1/2, right? Let's go ahead and restate this as 1/2 1 over root x, since that's what that means. All right, and so let's go ahead and, before we go any further, let's go ahead and restate this. Root x equals u minus 1. So now anytime we see root x, we can rewrite u minus 1 right there. All right, so let's go ahead and make that substitution right there. We've got 1 dx over 2 divided by u minus 1. Okay? And now let's go ahead and rearrange this equation so that we can get a match for what we see over here. And so this is going to be 2 times u minus 1 du equals dx. All right, so now we can go ahead and write this in as the integral of something over u to the fourth, and then we're going to go ahead and put all this stuff in, 2 u minus 1 du. Alright, so now we have something that we can work with. Let's go ahead and change the bounds real fast. U of 1, well, that's 1 plus the root 1, which is 2. U of 0 is 1 plus root 0, which is just 1. So we're going from 1 to 2. Okay, so pretty nice, pretty simple. Let's go ahead and move this 2 to the outside so that we have 2 integral from 1 to 2. And then we're going to go ahead and distribute this u to both terms so that we have u to the negative 3 minus u to the negative 4, and this is all du, right? U 1 minus 4 is negative 3, and then, of course, just 1 over u to the fourth is u to the negative fourth. All right, so all we have to do now is take the antiderivative of these two terms. So u to the negative 3 plus 1 is negative 2, divided by negative 2. Right, and then minus negative 4 plus 1 is negative 3, divided by negative 3. And we are going from u equals 1 to 2. All right, let me go ahead and shrink this so I've got space to work with. There we go. All right, so let's go ahead and distribute this 2 right now, since it looks like it will make things a little bit easier if we do. And so we have a negative u to the negative 2 plus 2/3 u to the negative 3, and of course u is going from 1 to 2. Let's go ahead and plug everything in. So we've got a negative 1 over 2 squared, which is 4, plus 2/3 u to the negative 3. So we have a 1 over 8. All right, that's our first term. And then we got the next term, everything's 1, so negative 1 plus 2/3. All right, so let's go ahead and start working this through. We've got, notice we have a 2 and an 8 here. Those are going to work together, so we're going to be left with, just a 1 up there and a 4 there. And so now to get these guys into a common multiple, we're going to multiply top and bottom by 3.